Today we're going to continue looking at section 5.6, which is graphing other trig functions. We are specifically going to be focusing on tangent. So we're going to look at the graph of tangent and the different variations. So one of the types of things that you're going to want to do is, once again, if I'm looking at a picture, we want to be able to come up with the equation. So here I'm giving us a multiple choice aspect to it, and you'll have something like this on your homework. So the first thing that we're going to want to do is let's look at number 1. I'm looking at all my different answer choices. And so as I'm looking, I'm noticing that like the A value is all the same and the B value is all the same. Because once again, if you remember, our basic definition is that we have y equals a times the tangent of, in parentheses, bx minus c plus d. Okay, so our a value is all 1 in this first example. Our b value is all 1. Some of them then have either a horizontal shift or a vertical shift. So if I'm looking at this particular graph, if you think about your different ordered pairs, remember in a basic tangent graph, you've got your vertical asymptotes, and then remember, like 0, 0 is the middle point, and it starts down and goes up. That's what a typical graph looks like. So once again, that's originally always 0, 0. Well, now we have to decide if we're dealing with any types of shifts. So looking at this first problem, I notice that I'm not at 0, 0, but I'm at this ordered pair right here, which is really the ordered pair 0, 2. So notice that it's gone up. So that means we have a vertical shift. So if I'm looking at my different options here, well, vertical shifts deal with the D value. So it's the number that's being added or subtracted outside of that tangent function. So since A has that 2 in parentheses, that's not a vertical shift. Same thing with D. So it's neither one of those. So I was able to eliminate that right away. So then the only other thing we have to think about is the fact that because we are shifting up, you are going to want to keep the sign the same. So notice that shifting up means I want that 2 positive. So it looks like C would be my answer. So same kind of thought process here with the second example. If I'm looking at my graph, I see that we've got, our vertical asymptotes in our graph inside, our equations here to choose from. We're dealing with 1 again as all of the A values and all of the B values. So once again, it's just a matter of, am I dealing then with a C or a D value? Am I dealing with a phase shift or a vertical shift? So this time when I'm looking at 0, 0, I don't see it going through. Instead, notice that I see that it has moved over to this point right here. So we have to figure out what that ordered pair is. Notice that each of my tick marks, if you can kind of see, every 2 is going up by pi over 2. So cut that in half. That means that right here, that value is pi over 4. So it looks like we're at the ordered pair of pi over 4, 0. So that means that we are shifting to the right. Okay, it didn't go up or down because we're still on the x-axis, but that middle point has shifted to the right. So if you remember, that then deals with the C value. So anything that is outside of parentheses, that wouldn't make sense because that's the vertical shift. So that means that B and C, because they don't have the parentheses, that's not going to be my answer. Now I have to remember, because I am shifting to the right, remember, we always want the opposite sign. So when I see that theta plus pi over 4, that's actually the incorrect one. I want to go down to letter D, where it's theta minus pi over 4. All right. So remember, the reason why your phase shift is really, though, it's C divided by B. But luckily for us, since the B value is 1, pi over 4 divided by 1 is why that C value matches the phase shift. But be careful, that's not necessarily always the case. All right, let's do a couple of graphs. Let's make sure that we can graph 2 full periods. Here's my equation, y equals -2 times the tangent of x plus 1. So once again, we want to identify our A, our B, our C, and our D in order to do these problems. A is the number that's in front, so that's -2. B is the number connected to x, so since I don't see a number, it's 1. I don't see any parentheses, which means there is no c value. The d value is the number that's being added or subtracted onto the function. We keep the sign the same, so +1. So I'm going to use this information, and first thing I want to do is there is no amplitude when we're talking about tangent because the height, it just keeps going up and it keeps going down. So there's no specific amplitude. Let's figure out the period. Remember, your period is always pi divided by the absolute value of b. Well, absolute value of 1 is 1, and pi divided by 1 is pi. So that is my period. Let's go ahead and do our 5 critical points. Because there is no c value, that means there is no phase shift, and then we can easily focus on the value for d for the vertical shift after we find our 5 critical points. So if you remember, our 5 critical points starts at -1/2 of the period. So -1/2 times pi is -pi/2, and then that's where we're undefined. Then I want to take -1/4 of the period. So -1/4 times pi is -pi/4. And then I want the opposite of a. So since a is -2, I want to make that a +2. The middle is always 0, 0. And now we're going the positive route. I want a +4 times the period. So that would turn then into pi/4. And then I want the a value, and a is -2. Then I want to take half of the period. So half of pi is pi/2. And then we're back to being undefined. Once again, because I have a value for d, that is going to deal with a shift, and that's going to affect the second part of our ordered pairs. So nothing changes in the first part, but I am going to, so I'm adding essentially 0 onto the first number, but I'm adding 1 onto all the seconds. So all of my x values stay the same. It's -pi/2, it's -pi/4, it's 0, +pi/4, and it's +pi/2. Anytime you're adding or subtracting onto something that's undefined, it's still going to be undefined. So our first and our last ordered pairs are still that. But 2 plus 1 would make that second ordered pair 3. 0 plus 1 would make that 1. -2 plus 1 would make that -1. So those are the ordered pairs that we want to plot. Now we have to label our axes. So remember, the x-axis, we're thinking about our radian values, whatever the bigger denominator is. So in this case, between 2 and 4. 4 is the bigger denominator. That's the tick marks that I'm going to use. So I'm going to make every tick mark go up and down by pi/4. Okay, I want 2 full periods. I'm also going to want both positive and negative values. Okay, so we're going to want -pi/4. I'm not going to write every single one. So then the next one on the left is -2 pi/4. Then we want -3 pi/4, -4 pi/4, -5 pi/4, and I can keep going on the left. On the right-hand side, the first tick mark is positive pi/4, then +2 pi/4, then 3 pi/4, 4 pi/4, 5 pi/4, 6, 7 pi/4, 8, 9 pi/4, and I can keep going and going and going. Okay, I'm going to be going up and down by 1. So 1, 2, 3, 4. I'm just going to label that 5 up there so I know that I'm going up by 1s, and then same thing, 1, 2, 3, 4, -5 down here. Okay, so now that I can clearly see what is labeled for every single axis, I can start plotting my point. So remember, I was going up and down by pi/4, but if you simplify, -2 pi/4 is -pi/2. So that second tick mark on the left is going to be my first vertical asymptote. Then -pi/4, +3. So that point is up here. 0, I want 1 then. Pi/4, we want to go down to -1. And then the second tick mark over, that's 2 pi/4, which then reduces to pi/2. So there is everything for my first one. I just have to connect those points. Remember, we got a little Kind of looks like a cubic graph a little bit, but notice that this time it's backwards because we have a negative number in front of our tangent. That's 1 period. I need to repeat that again. So you can either repeat it on the left or the right. Usually I go towards the right. So we already have our vertical asymptote. So then at 3 pi over 4, I want to be back up at 3. At then 4 pi over 4, which is pi, I want to be up at 1. At 5 pi over 4, I want to be back at -1. And then that next tick mark, 6 pi over 4, which is really 3 pi over 2, is where my next vertical asymptote is. And then once again, when I very carefully connect those points, put arrows at the end, notice how it's not quite touching the vertical asymptote. There's my 2 full periods. Okay, let's take a look at another one. We're going to graph 2 periods of y equals tangent of 2x minus pi. So once again, we need to identify our A, our B, our C, and our D. A value is 1 because there's no number in front of tangent. B value is 2 because that's in front of x. We do have a C value. It's the opposite sign, so positive pi. And then I see nothing being added or subtracted, so our D value is 0. So then no amplitude here, but we do have a period. Remember, your period is always pi divided by the absolute value of b. So pi divided by 2, that's going to be my period. This time we do have a phase shift. So remember, your phase shift is always c divided by b. So in this case, c is pi, and our b is +2. So our period and our phase shift happen to be the same this time. Okay, so let's list our 5 critical points. Remember, we always want to take the period and we want to start with -1/2 of the period. So I'm thinking -1/2 times pi over 2. That's going to get me my first number. So multiply straight across, that's -pi over 4, and that's when we're undefined. Then I want -1/4 of the period. So multiplying straight across, that's -pi over 8. And then I want the opposite of A, so I want -1. Then we're at 0, 0. Now I want to start doing the positive. So +1/4 times pi over 2 is +pi over 8. And then I want my A value of 1. Then I want +1/2 times pi over 2, so that's pi over 4, and we're back to being undefined. So now this time I do have a phase shift, so that means that it is the x values that are going to be affected. I want to add a positive pi over 2, and then remember your d value is nothing, so every single y value is going to stay the same. So now, once again, when you're adding your fractions, you got to have a common denominator. So -pi over 4 plus pi over 2. If you need to think of pi over 2 as a denominator of 4, well, that's because I multiplied the top and the bottom by 2, so think 2 pi over 4. So -pi over 4 plus 2 pi over 4 is pi over 4, and we are still then undefined. If you need to think of pi over 2 then as a denominator of 8 for the next one, that means that we multiplied the top and the bottom by 4, so 4 pi over 8 is what we should be adding. So if I have -pi over 8 and I add 4 pi over 8, that gives me 3 pi over 8, and we're still at -1. 0 plus pi over 2 is pi over 2, and we're still then at 0. Once again, pi over 8, we're going to add 4 pi over 8. That gives me 5 pi over 8, 1. And then finally, pi over 4, I'm adding 2 pi over 4, and that makes it 3 pi over 4, and we're back to being undefined. All right, so quite a few denominators there. So once again, when I'm thinking about my tick marks, I'm going to look at the biggest denominator number. So between a 4, an 8, and a 2, looks like 8 is the biggest number. And so that is what I'm going to focus on counting up and down by. So the first tick mark would be like a pi over 8, then 2 pi over 8, then 3 pi over 8, 4 pi over 8, 5 pi over 8, 6, 7 pi over 8, 8, 9 pi over 8. So you see how I'm going up by 8s each time? And then eventually, notice how like 2 pi over 8, well, that simplifies to pi over 4. So we are hitting every single one of these radian values. It's just that you're going to have to simplify and think about that. So it's the same idea going in the opposite direction. Negative pi over 8, negative 2 pi over 8, negative 3 pi over 8, and so on and so forth. And then as far as my y values, we can just be going up and down by ones like we normally do. So I'm just going to go down a couple, up a couple. There we go. Okay, so now that we have everything labeled, we can now start plotting our points and we can get 2 periods. So pi over 4 is where I want to start my vertical asymptote. Remember, that's the same thing as 2 pi over 8 when you simplify. So there is my first vertical asymptote. Okay, then I want to go to 3 pi over 8 and go down to -1, plot my points. Think about the next one then. 4 pi over 8 is what I didn't label here. If you reduce, that's pi over 2. So there's my 0. Then 5 pi over 8, we're up at 1. And then the next one, 6 pi over 8, which simplifies then to 3 pi over 4. And there is my vertical asymptote. So once again, I'm going to carefully connect. It looks kind of like a cubic. Put arrows on either side. Make sure it doesn't touch the vertical asymptote. And now I get to repeat that process. I already have the vertical asymptote. So the next one over, 7 pi over 8, I want to go down to -1. Then the next one would be pi, and that's going to be where 0 is. 9 pi over 8, we're going to go up 1. And then essentially 10 pi over 8, which if we simplified that would be 5 pi over 4. That's going to give me then my next one. So then here is my next graph. There's 2 full periods. We are done. Okay, let's do one more. So we're going to graph 2 full periods of y equals tangent of 6x minus 3. So once again, identify our A, our B, our C, and our D. So A is 1, B is 6. I don't see any parentheses, so C is 0. D is -3. All right, so no amplitude. So that means we start with our period. It's always pi divided by the absolute value of B. Well, absolute value of 6 is 6. Since there is no C value, there is no phase shift. So let's go ahead and let's get into our 5 critical points, because then we can very easily deal with our value for D, which is that vertical shift. So remember, we want -1/2 times the period, which is pi over 6. So when I multiply those straight across, we get -pi over 12, and that's where we're undefined. Then I want -1/4 of the period. So multiply straight across, we get -pi over 24. And then I want the opposite of A, so -1. Then we're at 0, 0. Then I want the positive. 1/4 times pi over 6 is positive pi over 24. That's when we're at then 1 for our A. And then finally, 1/2 times pi over 6 is going to be, pi over 6 is going to be pi over 12. And then we're back to being undefined. So because we have a value for D, we are going to want to shift. In this case, that 3 is negative, so we're not changing the x's, but the y's, we want to go down 3. All right, so -pi over 12 stays as it is, and then we do keep it as undefined. We'll still have that -pi over 24, but then now -1 minus 3 is -4. We'll keep the 0, and then 0 minus 3 is -3. Keep the positive pi over 24, and 1 minus 3 is -2. Keep the pi over 12, and then we will still have an undefined term. All right, so looking at my different axes, start with the x-axis. Each tick mark, looking at my different denominators, it looks like between the number 12 and 24, I'm going to be going up and down by pi over 24 each time. So the first one is a positive pi over 24 here, then 2 over 24. The next one would be 3 over 24. So that's actually going to simplify down to pi over 8. 4 pi over 4. Then we've got 5 pi over 24. 6. Then we have 7 pi over 24. 8. And then 9 pi over 24. So then 9 and 24 are going to simplify. 9 over 24 is going to simplify to 3 pi over 8. So that's this one right here. Then we have 10 pi over 24, 11 pi over 24, and I could keep going. Okay, on the other side, then we'd have negative pi over 24, negative 2 pi over 24, negative 3 pi over 24 would make that negative pi over 8, and so on and so forth. I'm going to be going up and down by ones. All right, and now I have everything labeled so I can clearly see what our tick marks represent. Let's go ahead and plot our points. So remember, negative pi over 12 is like negative 2 pi over 24. So that's this second tick mark over here where we have our first vertical asymptote. So negative pi over 24, we're going down to negative 4, plot our point. 0, we're at negative 3. Positive 24, we're at negative 2. And then the next tick mark would be then that positive pi over 12 because it simplifies down because it's really 2 pi over 24. And so there is our first period of this tangent graph. But now, since I need 2, we're going to repeat the process. So vertical asymptote, then at pi over 8, we're down at negative 4. Next one, we're at negative 3. 5 pi over 24, we're at negative 2. And then this 6 pi over 24, which is then really pi over 4, is going to be that next vertical asymptote. Once again, if I connect my points there, there's my tangent graph, and there are my 2 full periods. Okay, so that is us understanding the tangent graph and doing some different variations.